Alright everyone, so that first video got a little bit cut off and I didn't realize that, so I'm just going to wrap up this last problem that was happening in the first video on problem 12. And in the video I was addressing the two different answers, and so in this first problem to solve for x, now we have to subtract 4, so then we can just have our square root of 6 subtracting 4, and when we subtract 4 in this one, then it'll just be a negative square root of 6 subtracting 4. And then, if you don't want to write them separately, you can write them together. The radical, the square root, is to be written last, and then since there's a positive and a negative, we'll put the plus or minus in between, and then this negative 4 or minus 4 that's hanging out here will just go in front. And we can't combine these because these are not like terms, so leave it like this or write it like this, but then that's how you would do and finish up problem 12. So in the second part of the video overall, we're going to tackle the problems that we put squares around. And these problems are all in standard form. They have more than one type of x. They all have, an x squared and an x. So with that, we do want to make sure that every problem is in standard form and that it equals 0. We're going to try to factor it because that's our most efficient way to do this. And if we can't factor it, then we'll use our quadratic formula. All right, so just walking through these problems, starting with the first one, I'm going to make my x. It is in standard form. It does equal 0. Since I am factoring, I am going to try for a GCF first, which there isn't one. So making my x, I need factors of 12 that get me to negative 7. And so that would be a 4 and a 3. And just a reminder, since we have negatives on the top and bottom, we'll have negatives on the side as well. So since the factoring is going to work, I'm going to make my parentheses, setting it equal to 0. I'm going to drop in those x's, and then before I complete the loops here, I want to see is x and x enough, and it is because x times x is this x squared. So what I'll use is this x and multiply it through this loop to get negative 4x, and then I'll ask myself x times what can make this negative 3x, and that would be a negative 3. Now that I have factored it, so it was factorable, no GCF, I did 3 terms, I will do that zero product property, which if you remember we drew this arrow over, just means that we're going to set our parentheses equal to 0, and we're going to solve. And these two are pretty simple. In this problem I would just add 3 over, so one of my two solutions is 3, and here I would add 4, and the second solution is 4. Alright, the next box problem was number 4. So again, I'm going to try to factor it. It's in standard form equaling 0. There is not a GCF, so I'm going to look for factors of negative 10 that make 2. And as it turns out, there aren't any factors of 10 that make 2. 5 and 2 being on the side would give me 3. So since this isn't factorable, we're going to use our quadratic formula, and we will get a and b and c from our standard form. So a in this problem is 2. B is 2, and C is negative 5. And then just to have it next to us, we're going to make it x equals, we're going to take the opposite of B, so 2 becomes negative 2. We'll plus or minus, make a bigger square root. In the square root, we'll take B and square it, so 2 squared is 4, minus 4 times A and times C. And then all of this will be over 2 times A, so 2 times 2 is 4. From there, the work goes into the radical, what's inside that check mark. So notice I'm leaving the negative 2 plus or minus and over 4 the same. You can get a calculator and type in 4 minus 4 times negative 5. Make sure you press that negative button. But what your calculator will do is when it's choosing between subtraction and multiplying in the order of operations, it's going to multiply first. And I think it's easier to do negative 5 times 4 for 20. Or sorry, negative 20, and negative 20 times 4 for negative 80. And then what happens is this 4 subtracting with 80, they're going to come together like that, and they're going to become a positive. Just 1 second, just double checking something here. Oops, and you know what? I realized I made a mistake here. So before I go on, I did 4 times A. A is 2, so let's fix that. That's a 2. Which turns this actually, 4 times 2 is 8, and 8 times negative 5 is negative 40. So quick correction. So when I bring the subtraction sign here with the negative, right, they're going to make a positive now connecting 4 and 40. But if you do type it into your calculator, you will get a 44 in there. So we can bring up now our good, better, and best answers. This is a good answer, and for some of you, this is where you'll stop, and that's just fine. The better answer, excuse me, I'm going to find one of my factor pages. Hopefully I brought one back. Let me pause this video. So to get a better answer, what I can check to see is, working with this radical, is 44 perfect? It's not a perfect square, but maybe it has factors that are perfect. So just checking out 44, and we always leave out 1 in 44, 4 is perfect. So what I can do is break this 44 down into a square root of 4 and a square root 11, and then the negative 2 plus or minus over 4 can still be there, but then the square root of 4 can become a 2 and the square root of 11 can stay that. So this is a good answer. This one's a little better. The best answer is going to come from that triangle I've shown you before. The square root of 11 does not get to be part of the triangle. And I'm just going to look, is there a number? What number can go into all of those numbers? And that would be a 2. So it's kind of like factoring out a 2. So when I divide this term by 2, I get negative 1. Divide this by term 2, and I get 1. And there's the 11 safe inside that check mark. And if I divide this by 2, I get 2. So this is a good answer, this is better, and this is best. You should try for the best, but it's okay if you mess up and just go for the good. Alright, next box problem is number 6. So this one is not in standard form. So while I'm going to have the 8x squared minus the 16x, I'm going to have to bring this 5 over by adding 5, and that's going to be an adding 5 on the other side. So now what I can do is check to see, is this factorable? So I'm going to look for, are there, let's back up. Is there a GCF? And there's not. So are there factors of 40 that get me to negative 16? So if we do a quick look here, as it turns out, there are no factors of 40 that get me to 16. So then what I'm going to do is go back to that quadratic formula. And you know what? I just realized this. Sorry, I guess I'm making more mistakes. That is not my box covered up. That is a 3. So let's fix that real quick, because that changes everything then. Okay, so that's actually 3x squared. And so now what I'm looking for are factors of 15 that get me to negative 16. And that does work. That is going to be a 1 and a 15, with them both being negative. So sorry about that. Crossed off my problem and I couldn't see what it was. So now that it's factorable, I'm going to go ahead and make my parentheses, drop those x's in. And x and x are not enough. X times x is x squared, and we're going to need a 3x squared, so I'm going to put a 3 with one of them. And now I'll draw my loops to make these numbers. And since x can make either of these, the 3 can only make one of these two. So 3 times a negative 5 can make negative 15, and then x times a negative 1 can make the negative 1x. So now that's in factored form. Following my little cheat sheet, I will, in factored form, I'm going to then do the zero product property. So set each of these parentheses equal to 0, and then I'm going to solve. Alright, so this one's our simpler one. Just add 5 over. So one of our two solutions is 5. And in this one, I'm going to add 1. And then I'll divide by 3. So my second solution is 1/3. Alright, let's flip to the back, and we got 2 more problems to do. So in the first problem, again, it's in standard form. It equals 0. I'm going to try to factor it first. There is not a GCF. So what I'm going to look for, are there factors of 6 that can get me to negative 8? And there are not. There are not factors of 6 that can get you to negative 8. So there's that not factorable part. So I will use my quadratic formula now. That's what my map says. So A is 2, B is negative 8, and C is 3. And now we can follow the quadratic formula. So it's going to go x equals opposite b, so I'll put 8 plus or minus. We're going to take this number and square it, so negative 8 squared, negative 8 times negative 8 is 64, minus 4 times a times c, and then all of this is over 2 times a, so 2 times 2 is going to be 4. So just like before, I only have to bring my work to the radical, to the check mark, and again, you can type this in if you want. What your calculator is going to do is 4 times 2, which is 8, and 8 times 3 is 24, and then 64 take away 24 is a 40. So again, this is a good answer. Let's see if we can make it better. So 40 is not perfect, but there are factors of 40 that could be perfect. And as it turns out, 4 with 10 is what we'll use. So I'm going to break the 40 down into a square root of 4 and a square root of 10. And then, just like before, the 8 and plus or minus over 4 will stay the same. Sorry, you can't see that. And then the square root of 4 becomes a 2, and the 10 will be stuck inside that square root. So this is better. And now I'm going to draw that triangle, leaving the square root of 10 out of it. And is there a number that goes into all of them? And so right now it seems to be 2's been going into all of these. So I'll divide this by 2, which is 4. Divide 2 by 2, which is 1. The 10 is protected. And divide this by 2, and we get 2. So good answer, better answer, best answer. And our final problem. So in the final problem with number 9, it's not in standard form. It is, except I need that 9 on the other side. So I'm going to subtract 9, which puts it at minus 9 on this side. So now I'll look for a GCF. First step of factoring, there isn't one. So let's see if the x works. I need factors of negative 9 that get me to 2, and there aren't any. So again, this is not factorable. So we are going to have to use our quadratic formula one more time. So I've identified A, B, and C. And now using the quadratic formula, we're going to make it x equals opposite b, so we'll use negative 2 plus or minus, and we're going to take b and square it, so that's 4 minus 4 times a and times c, and then all of this is over 2 times a, so all of that's going to be over 2. Okay? So now what we're going to do, where are we? We're on number 9. Okay, is again, you can use your calculator if you want to do the math inside that square root, but what's going to happen is it will do 4 times 1 times negative 9, which is negative 36, and then your subtraction sign and your negative sign are going to come together and make a plus sign in between 4 and 36. So that's going to be a 40, and again, this is a good answer. But, like in the last problem, it had a square root of 40. 40 isn't perfect, but we can break it down into its factors. And since we just did this one, I already know that square root of 4 and square root of 10 are going to work. So the negative 2 plus or minus over 2 is still there. The square root of 4 becomes a 2, and the 10 is protected. So that's a better answer. And then the best answer will be this simplifying. Is there a number that goes into all of those? And just like all of the problems before, a 2. I can divide all of these by 2. So I get negative 1 from here. Divide this by 2 and I get 1. The 10's protected, and then this 2 divided by 2 is 1, which technically you don't even need a denominator of 1, but if you just want to keep up with what we're doing, that's fine. So this is good, this is better, this is best. And that is your review for Showcase of Learning number 6.